Greetings, we'll cover a few details about G.H. Hardy in his life in a succinct manner. Here is a short rundown of his early years, education, career, persona, notable works, accolades, and demise. Mathematician from England renowned for his work in number theory and mathematical analysis, he is renowned in biology for developing the Hardy-Weinberg rule, which is a cornerstone of population genetics. Most people outside of the discipline of mathematics are familiar with G.H. Hardy thanks to his 1940 essay A Mathematician's Apology, which is frequently regarded as one of the best glimpses into the mind of a practicing mathematician, written for the layperson. Also known as Godfrey Harold Hardy, famous as English mathematician, known for his contributions in number theory and mathematical analysis. Born February 7, 1877, Cranley, United Kingdom. Died December 1, 1947, Cambridge, United Kingdom. Father, Isaac Hardy. Mother, Sophia Hall Hardy. Spouse, never married. Education, Trinity College, Cambridge. Works and achievements, reformed British mathematics, known for his extensive achievements in number theory and mathematical analysis. Notable students, Srimivasa Ramanujan, more. Academic advisors, Augustus Edward Hoff Love, E.T. Whittaker. On February 7, 1877, Godfrey Harold Hardy was born in Cranley, a thriving community in Surrey, England. His mother, Sophia Hardy, worked as a teacher at Lincoln Teachers Training School, while his father, Isaac Hardy, was the bursar and art master at Cranley School. Isaac and Sophia both hailed from low-income households, thus despite their great intelligence and prodigious mathematical abilities, they were unable to pursue higher education. Harold was the first of the couple's 2 children, and Gertrude was Harold's younger sister. The brothers and sisters were quite close. From the moment he was born, Harold Hardy was a mathematical prodigy. By the age of 2, he was reportedly able to write figures up to 1 million. He was required to routinely attend church services. Because he was raised in a pious Victorian home, he spent his time factoring the numbers on the hymn board there, though. Hardy enjoyed cricket just as much. He accidentally hit Gertrude with a bat one day, when they were playing, severely damaging her eye to the point where she needed a glass eye. Interestingly, the event brought the siblings closer and they remained loyal to one another for the remainder of their lives. At Cranley School, he started his schooling. Later, he claimed that as a young man, he had no interest for mathematics. He merely saw the subject in terms of exams and scholarships, and he discovered that mathematics was highly helpful if he wanted to outperform other boys. He was awarded a scholarship to Winchester College in 1889, an independent boarding institution that followed the British public school model. The teaching of mathematics at the institution was renowned. He went there to study from 1890 to 1896. Hardy disliked going to school since it was too demanding for a timid and weak youngster like him. He loved cricket, but he never participated in coaching. But because of his academic prowess, he was given an open scholarship to enroll in Trinity College, Cambridge, in 1896. Hardy started his studies at Trinity under the tutelage of R.R. Webb, a math instructor. But he soon discovered, to his dismay, that Webb was less engaged in teaching the topic and more concerned with getting his students ready for the dreaded Tripos exams and seeing them become wranglers. Hardy had no interest in any of that. He initially considered switching to history, but eventually changed coaches and quickly began studying with Augustus E. H. Love. He taught him the true meaning of mathematics, and that is where he got his first idea of analysis. He also completed his Tripos, while studying under Robert Alfred Herman. On the advice of Professor Love, he started reading Camille Jordan's Cours d'analyse de l'école polytechnique at some point during this time. The book, which introduced him to the continent's mathematical traditions, left a lasting impression on him. He also joined the Cambridge Apostles at this time, a campus secret society. It was only accessible to exceptional students, and Hardy quickly gained popularity among the group thanks to his quiet charm, razor-sharp intelligence, aesthetic sensibility, and enjoyment of deep conversations. G.H. Hardy started working as a lecturer at Trinity College in Cambridge in 1906. Here, he only taught 6 hours per week and dedicated the rest of his time to study, authoring numerous publications on problems related to the convergence of series and integrals. Hardy's 1908 book, A Course in Pure Mathematics, which for the first time attempts to present a comprehensive description of number, function, limit, etc., is widely renowned today, despite the fact that he disregarded most of his earlier works as being of little significance. Up until that point, applied mathematics was the main focus of British mathematicians. When Hardy started working with John Eden's Littlewood in 1911, it was a turning point in his career and the start of a 35-year association. Together, they started working hard on mathematical analysis and analytic number theory, and in 1912, they published the first set of articles they had written. Early in 1913, Hardy got an odd letter from Srimavasa Iyengar Ramanujan, an unidentified Indian employee working for the Madras Port Trust, dated January 16. There were 9 pages of math in it. Hardy initially thought it was a scam, but after reading it more carefully, he found it remarkable and requested Littlewood to look at them. Then in 1914, he made plans to bring Ramanujan to Cambridge. The moment Ramanujan arrived in London on April 14, Hardy and Littlewood got to work looking over his notepad, which was full of innovative ideas. But soon after, when World War I started, Littlewood enlisted in the Royal Artillery to serve in the military. Hardy had also offered to enlist, but when his application was turned down due to health issues, he decided to stay behind and carry on with his studies at Cambridge. He was appointed the Cayley Lecturer at Cambridge at some point. Hardy began filling in the gaps in his mathematical education after realizing that Ramanujan was self-taught in order to avoid upsetting his sources of inspiration. The two mathematicians collaborated to publish various papers up to 1919. The civilian chair of geometry at the University of Oxford was made available to G.H. Hardy in 1919. He accepted the possibility of leaving Cambridge because he was by that point extremely angry with the administrators of Cambridge University for letting the renowned mathematician and pacifist Bertrand Russell go. He remained a Fellow of New College at Oxford through 1931. They began working together after the war, when Littlewood moved back to Cambridge, and despite being thousands of miles away, they proceeded to co-publish a number of highly significant works. Hardy traveled to the USA in 1928 to participate in an academic exchange program. Oswald Veblen replaced him in Oxford, and spent the academic year 1928 to 1929 there. He delivered the Josiah Willets Gibbs speech, as well in 1928. Hardy received an invitation to accept the job of Sadlerian professor at Cambridge in 1931. Hardy never got married. His sister Gertrude used to take care of him in his later years. He also had a lot of friends, all of whom he got along with. He had a strong enthusiasm for cricket. He used to watch cricket scores closely every morning. He would research Australian cricket scores when the English cricket season wasn't in session. Maynard Keynes famously remarked that Hardy would have gotten quite wealthy if he had studied the stock market with the same enthusiasm. Although he declared himself an agnostic, he saw God as his greatest opponent. In an effort to trick God, he frequently brought heavy sweaters, an umbrella, mathematical papers, and students' exam scripts to the cricket field. According to his view, God would send brightness if he thought rain was imminent. Hardy was an outspoken peace activist. He found the two world wars to be extremely sad, but they also made him enraged that Europe had become involved in such pointless carnage. When it comes to mathematics, G. H. Hardy is most known for his work on the Hardy-Ramanujan asymptotic formula and the Hardy-Littlewood circle method, while in biology, he is best known for the Hardy-Weinberg principle, which relates to population genetics. His 1940 work, A Mathematical Apology, is also well recognized. He had referred to it as a apology, but actually meant a formal justification. He had added some personal information to it, providing us a glimpse into the mind of a practicing mathematician, despite the fact that it mostly deals with the aesthetics of mathematics. The most significant honors given to G. H. Hardy were the Smith's Prize in 1901, the Royal Medal in 1920, the De Morgan Medal in 1929, the Chauvenet Prize in 1932, the Sylvester Medal in 1940, and the Copley Medal in 1940. 1947, Hardy was selected as a Fellow of the Royal Society in 1910, at the age of 33. From 1926 to 1928 and once more from 1939 to 1941, he served as the President of the London Mathematical Society. He was awarded an honorary doctorate by Harvard University in 1936. Hardy suffered a heart attack in 1939, which had an impact on him, mentally and physically. His health had started to rapidly decline by 1945, and by 1946, he was essentially housebound. He was very upset by this. He attempted suicide in the early months of 1947, by overdosing on barbiturates. Despite surviving the effort, he passed away in Cambridge on December 1, 1947. He was 70 years old at the time.